Hey everyone, it's Chloe here from Tutoring Your Way and I'm back for another video. The concept that I'm going to be explaining at the end of today's video applies to Year 12 further math students studying the Networks module, but everything else I'm going to talk about beforehand applies to everyone. So recently I had a student come to me in a tutoring lesson with a certain concept and she said, I really don't understand this concept, can you explain it? Now we worked on this concept for a whole hour, the whole lesson, and both of us just kept getting the wrong answer. It was Dijkstra's algorithm. For those of you that do further maths, it's a very complicated way of finding the shortest path from A to B in a network. And you have to do this whole massive table, and there was all these numbers. We just kept getting the wrong answer. After the lesson, I found a YouTube video that explains the concept visually. So rather than being in a table format, it's set out more in a graph format or a visual format. There are different types of learners and different learning styles. So the main three, you've got auditory, which learns by listening. You've got kinesthetic, and they learn by doing, so using their hands and moving around, stuff like that. And the last learning style is visual. So they learn by seeing things or seeing people do things and having those people explain what they're doing while they do it. Seeing things represented as networks or graphs or diagrams, pictures, whatever helps you. I lean more towards the visual side, but I think representing things visually can help any math student. If things in maths aren't represented visually, they just look like gibberish. They just look like numbers and letters on a page, but often representing things as a graph or a diagram can really help that information solidify in your brain. The more ways you can be exposed to a particular piece of information, the stronger the neural pathways in your brain that represent that concept will become. So if you have something told to you and you have it represented on a diagram, and then you practice it by doing it, that's the kinesthetic part, then that neural pathway is going to be so much stronger than if you just saw the concept. It doesn't just get straight away absorbed into your brain. The most efficient way to learn by far is by doing. It's by semi-learning a concept, so you have a vague idea of it, and then teaching it to others. And that will identify gaps in knowledge because you'll be teaching it and the person will ask questions and you'll be like, oh, I don't actually know the answer, and you have to go back and study it. And you make mistakes. You do math questions and you make mistakes and you realize what mistake you made. So then you'll go back next time and you won't make that mistake again. Or maybe you'll make it a lot of times, but you'll be reminded about that thing. Whereas if we don't make mistakes, then how can we learn? So if you want to stick around and learn about Dijkstra's algorithm, watch the video in the link below, then watch the rest of this video. And then try it for yourself, because making mistakes is how we learn. If you're not sticking around, I'll see you next time.
So going by what we did in the video, you start at the starting point and all these numbers have like a weight. So you can think of it as infinity, or you don't really need to think of it as anything. This one's 0. We start at S and we're going to finish up at F. So we bridge out to all the possible pathways. So the possible pathways are B, and we do this weight 2 plus 0. So the weight of B is 2. This one as well. So 3 plus 0 is 3. And then you go to the end of all the pathways. So the two ends that we've got here is A and B. So 3 and 2, the lowest one is 2. So we're going to do 2. So we do it to all the possible pathways. Well, there's only one, which is to D. So we do the weight of this 7 plus the 2. So the weight of D is 9. Now we go to our two ends. These are the two ends at the moment. The lowest one is 3. So we go from 3, A to C. So 3 plus 6 is 9. Now they're both 9, so we can just pick one. We'll just pick C. So then we go C to all possible ones, which is just F. 9 plus 4 is 13. And we've got to check this one as well, because now I've got two possible ends. So 9 plus 3 is going to be 12. So remember, we replace it if we can find a lower alternative. 12, so the shortest path is 12. So much easier than the table. Okay, let's have a look at this one as well. Clear all that. If we start at S, so we're going to branch out. So branch out to A. This was 0. 0 plus 1 is just 1. And then this one is just 5. The lowest one out of those two is 1. So we go from 1. Branch out all possible ways. So this way I've got 3 plus 1 is 4. And then go out this way as well. 1 plus 9 is 10. And then out of all those ends, the lowest one is 4. So we'll go from 4. Only other possible one is here. So 4 plus 4 is 8. So we're going to replace that 10 with an 8 because 8 is lower than 10. And then we've got two ends, 8 and 5. So 5 is lower, we go for 5. B to F, so 5 plus 6 is 11. And we've got to test this one as well. So 8 plus 2 is 10. So we're going to replace that. And it will be 10. And once you've figured out the route that you took that was the shortest, you just go back and highlight it. So you can write down the order if that's what the question asks. So to get that 10 pathway, we came from here, 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 here. So your path would be S, A, C, D, F. I hope that has cleared it up a lot better than I could in the lesson. I think this visual technique is about 20,000 times better than the table technique. Have a good rest of your week, and I'll see you next week.